Good day, everybody. I am so excited to finally be doing this video. It's been on my mind for quite some time, and I have now decided to finally put pen to paper and do this video. I really hope you enjoy it. Please share it, and please like my channel if you do. So let's get started. So this video is going to be all about long division and why we shouldn't be teaching long division to our children and why we should teach them an alternative method. Over the years of teaching in classrooms, I have come to the realization that kids don't understand long division, and a lot of parents nowadays revert back to that feeling they had when they first started long division, and that generally explains their attitude towards mathematics in general. And for this reason specifically, I've now decided to do this video and show them that there's more to mathematics than just long division. Our first experience with long division usually emphasizes what our experience will be towards mathematics throughout our primary school years and into high school. And for this reason, a lot of 30-year-olds have started hating mathematics because when they started with long division, it was their first bad experience. So let's look at an alternative method. Before I actually show you the alternative method, I'd like to explain to you why it is necessary. So I'm going to start this with an example. I'm going to do 6,623 divide by 91. And to do this, a lot of schools teaches our children the question, does McDonald's sell cheeseburgers? So this was the acronym that I actually taught when I started teaching, and it stands for divide, multiply, subtract, check, and bring down. If we apply this algorithm to our division sum, it will look something like this: 6,623 divided by 91. And when we do this, we can clearly see that we first have to divide. Now, before we have to divide, we have to know our times tables, and a lot of kids at school do not know their times tables up to 12, never mind to 91. So the first question we obviously ask is, can 91 divide into 6? And our answer is an obvious no. But now, if we argue this and the language and thought patterns of a grade 3 or grade 4 learner, we are asking ourselves, can 91 go into the number 6? But when we actually analyze the number 6 here, that 6 actually means 6,000. And 6,000 can be divided by 91, but in our case, we are saying no. So let's go further and say, okay, 91 can't go into 6. 91 also cannot go into 66. And now we have to put 91 into 662. But because neither you or I know our 91 times table, this is going to be tricky. And that is where I'm going to stop. Because at this point, a grade 3 or a grade 4 learner will also stop. They will not know how to continue with this. They wouldn't know where to look or what to do. And this is the reason why I don't teach this method, because a lot of kids get stuck here. They don't understand what they are doing. Asking yourself if 91 goes into the number 66 doesn't really make sense if you actually look at the values of 66, because that 66 is 6,600 and 91 can most definitely go into 6,600. However, we are now saying it can't. And that is where a lot of kids just put on the brakes and refuse to go further. On top of that, when a grade 3 learner leaves grade 3, they are supposed to know the values of the digits. So that is the emphasis within the foundation phase, is teaching them the value of digits in certain places. So when we tell them that is just a 6 and 91 can't go into 6, we are actually defying the whole object of what they were taught. And that is the reason that I've scrapped this method. It doesn't make sense to our kids. Arguing about it doesn't make sense to them. Asking them to just practice it also actually defeats the whole object. So I'm going to now show you how to do this exact question using an alternative method. Before I actually go into the alternative method, I want to show you what actually happens when we add and subtract. So I'm going to start with the add and subtracting, and when we do addition and subtraction, let's do it simple. We say 5 minus 3 equals 2. We can also, from this argument, that 3 plus 2 will give me 5. We can also argue that 2 plus 3 will also give me 5, and that 5 minus 2 will give me 3. This is a basic principle that kids are supposed to be able to interpret and argue about in a grade 3 environment. And that is our first step to actually division and multiplication. And from this, we can actually look at division and multiplication. So let's continue. When we now apply the same concept, we can argue that 5 times 3 will give me 15. And therefore, 3 times 5 will also give me 15. From these two equations, we can now deduct that 15 divided by 5 equals 3, as well as 15 divided by 3 equals 5. And when children in grade 2 and 3 start learning their times tables, we often tell them to say, for example, if we do them backwards and we ask them, what is 48 divided by 8? Then we actually tell them count in 8s. So what we are doing is we are writing out the multiples of 8. 8, 16, 24, 32, 40, and 48. Therefore, what we are actually asking is 8 times what will inevitably give me 48. And then we conclude that in this case, it's going to be 1, 2, 3, 4, 5, 6. So if 8 times 6 gives me 48, then 48 divided by 8 will give us 6. And this is the principle that I'm going to use when doing bigger division sums, and this is called our alternative method then. So the alternative method is based on the principle I have just explained, and I'm now going to apply this principle to the division sum we did earlier, where we said 6,623 divided by 91. So we first have to find the multiples of 91, and this is our times tables, but because neither you or I know our 91 times table, we are going to have to just add a little bit. And when we do this, I usually advise the kids to do 9 multiples. But when the number is big like 91, 4 or 5 usually does the trick. So in this case, I'm going to do 4 multiples. So we're going to do 91. 91 plus 91 is 182. The next one is 273. And the next one is 364. And these are the multiples: 1 times 92, 2 times 91, 3 times 91, and 4 times 91. Because we have quite a large number that we have to divide, the 6,000, we are also going to do 10 times 91, 20 times 91, 30 times 91, and 40 times 91. And these are quite easy at the moment because right now we can just put an extra 0 at the back. And now we are not adding the 0, please. We're just putting it at the back. The number values have changed. When we add 0, it actually means nothing. We don't change the value. So let's just write out those 4 multiples. Okay, great. Now from here on, we are actually going to do the principle that we applied earlier. So we are going to have to mention that we have to get to 6,623, and we are only allowed to use the numbers that we've written here. So our goal is to get to 6,623, and to do this I'm going to minus. So the biggest number I have here, the biggest multiple, is 3,640, and we are going to minus that. So when we minus, let's go, 3 minus 0 is 3, 20 minus 40 can't, so I'm going to just use an extra 100 there. So we've got 120 minus 40 is 80, 500 minus 600 can't, so I'm going to use 1,000. 1,500 minus 600 is 900, and 5,000 minus 3 is 2,000. Okay, great. Our next multiple that we can use is the 2,730, and that is 2,730. We are going to use that, and we are going to minus again. So 3 minus 0 is 3, 80 minus 30 is 50, 900 minus 700 is 200, and 2,000 minus 2,000 is nothing. From there on, our next multiple that we can use is 182, 182. And when we minus that, 3 minus 2 is 1, 50 minus 80 can't. I'm going to use 100. 150 minus 80 is 70, and 100 minus 100 is 71. Okay, great. So now we are going to ask ourselves, okay, but what did I multiply with? So the 3,640 I used meant 40 times 91. And the 2,730 I used meant 30 times 91. And the 182 I used was equal to 2 times 91. And I can't multiply anything by 91 to get to 70 right now. So we are going to say, okay, but how much did I multiply 91? I multiplied it a total of 40 plus 30 plus 2. So our answer to 6,623 divided by 91 means what? I actually divided it, and that gave me a total of 72. This number now becomes our remainder, because that is what we had left after multiplying and adding our multiples of 91. And that is our answer, 72, remainder 71. So based on the alternative method I just showed you, I am now going to compare what long division and the alternative method would look like if I actually compare the two and put them right next to each other. And to do this, I'm going to use the sum 384 divided by 24. And when we use long division to do it, it will look like something like this, 384 divided by 24. To do this method, you actually do need to know your times table, so I am going to use the ones I know already. So 24 goes into 3 can't, 24 goes into 38 once, 1 times 24 is 24, and we are going to subtract that. That gives us 4 and 1. 24 can't go into 14, but we can bring this 4 down. 24 goes into 144 6 times, and 6 times 24 is 144. We are going to minus, and that is our answer. So 384 divided by 24 equals 16. So the alternative method obviously is a little bit more writing, but because the children can stop at any point, it actually makes it quite easier and more reliable. So the first thing we have to do is we have to write out our multiples. So 24, 48, 72, 96, and 120, and 144. What I normally tell the children I teach is that they can do these multiples 9 times, and they can stop there. However, if it is big numbers like 91 or 484, then they do as few or many as they can, at least 4 or 5 at least. That just gives them more numbers to work with, but even 3 will actually do the trick. So because our number isn't that big, I can just put the 0 here at the back. I'm doing it in another color so that we can differentiate between our multiples. And these are the ones that I'm going to use. The number is 384, so I could have actually just stopped here at the first 0, but I just carried it through. And now we are actually doing our sum, and we are going to say 384 is our target, and we are going to use these multiples. The biggest one I can use is the total of 240. And when we minus 240 there, that's 4, and that's 1. Closest here is 144. There's 144, and subtract, and our answer is 0. Now we ask ourselves, okay, which multiples did I use? I used the 240, which included the 0, so this 240 was equal to 10 times. This was equal to 1, 2, 3, 4, 5, 6 times. I didn't use the 0, so this is just 6 times. And that gives us a total of 16 times. So that means 384 divided by 24 is 16. And as you can see, my answers are exactly the same. But now I want to actually compare the methods. So what I want to show you here is here when we subtracted the first one, we got 244. So on the left, with our original long division sum, I'm going to erase this one, we can see that there is a placeholder. So technically there would have been a 0. And there you've got your 240. 144 was your answer. There's our 144 on the right. And all our steps were basically exactly the same. However, when we did this one, it was an algorithm. We specifically just did the method. We didn't understand what we were doing. We asked ourselves, can 24 go into 3? Can 24 go into 38? But these 38 here actually means 380. So the two methods look very similar. They actually get to the same answer, and the alternative method is just one that actually makes more sense to our children. When they apply the logic here, then it applies to what they are argumenting, and when they actually understand the alternative method and they've practiced it throughout grade 4 and grade 5, then when they do get to grade 6 and they want to do the long division, they actually can. And they actually have a fallback as well. So when they don't come right with the long division, they can still use the alternative method. But when you understand the alternative method, the long division actually just makes sense. So that is my take on the alternative method to long division, and I really, really hope this has value to you as well. Please comment on this video and share it. I'd really like some feedback from the public about it. At this point, I had a lot of feedback from parents and teachers, and those teachers that talked with me have actually started teaching this method as well. So it is just a method that I love teaching, and I really do feel it actually builds confidence and don't break the kids down. But yeah, thanks so much for your time. I really enjoyed making this video, and I hope to speak to you guys again soon. Have a lovely day.